Hi class. Today we'll look at addition rules for probability. We will now begin learning various tools for calculating more complex probabilities. To begin, probability is always a decimal number between 0 and 1. So a probability of anything happening is always going to be between 0 and 1. And we can think of these as percentages if we want to talk about the chance of that event happening. However, in math classes, we traditionally write probabilities as decimal numbers. The closer the probability is to 0, the less likely the event is to happen. And the closer the probability is to 1, the more likely it is to happen. So 0 means it cannot occur. 1 we can think of as 100%, means it will occur. And the closer we are on this spectrum, the more likely that event will occur. The complement of an event E, which we denote by E superscript C, this is read E complement, is the set of all outcomes in the sample space that are not in E. So the complement gives us the not statement. So E is going to contain some outcomes, and the complement is not E, and that's going to contain the remaining outcomes. Okay, so let's look at an example. Describe the complement of each of the following events. Choose a vowel from the English alphabet. Okay, so we have all of the vowels, A, E, I, O, and U. Since there are 26 letters and 5 of which are vowels, the complement contains the other 21 letters, which we actually call consonants, if you remember from an English class. So the 21 consonants are the complement, consist of the complement of this event. Okay, let's look at another example. Out of 31 students in your statistics class, 15 are out sick with the flu. Since 15 are out with the flu, the complement contains the other 16 students who are not out sick with the flu. Okay? Now, really, this is all we can say. They're not out sick with the flu. They may be in class. They may be out sick with something else. But all we know is that 16 are not out sick with the flu. We can calculate the probability of the complement using the following fact. The probability of the complement is 1 minus the probability of the event. Using algebra, we may also write the probability of the event is 1 minus the probability of the complement. This is useful since sometimes it's easier to calculate the probability of the complement or the probability of the event in some cases. Again, let's look at an example. So find the probability of rolling 2 dice and not getting doubles. We could list out the sample space, and we saw this actually in section 4.1 for this event. Remember, when we rolled 2 dice, we had the 36 possible outcomes. And we actually created our tree diagram. We used our tree diagram technique to create this sample space. And we could list out all of the possibilities that satisfy the event, not getting doubles. However, in this case, it's actually easier to count the number in the complement. So notice there are a total of 36 outcomes, and it's very easy to count all of the rolls that are doubles. The doubles would be I roll a 1 and a 1, I roll a 2 and a 2, I roll a 3 and a 3, a 4 and a 4, a 5 and a 5, and a 6 and a 6. That's very easy to list. So the probability of not getting doubles using our formula is 1 minus the probability of getting doubles. Well, there's 6 doubles out of a total possibility of 36. So we have 1 minus 6 over 36, which is really 36 over 36 minus 6 over 36, which gives us 30 over 36, or we can reduce that to 5/6, Or if we prefer a decimal value, we can write it as 0.8333. So the probability of not getting doubles is approximately 0.8333. Note that traditionally we round all of our probabilities to 4 decimal places, and this was stated in our previous section. Events can also be combined using the words or and. For example, what is the probability we choose a freshman or a math major at random from UNA? We could also ask what is the probability of choosing a math major that is a freshman at random from UNA. Notice that this second statement is actually an and statement, right? Freshman and math major, right? A math major that is a freshman is a math major and a freshman. Now, for the purpose of our class, we will only focus on our or statements. This leads to what we call the addition rule for probability. For 2 events, E and F, the probability that E or F occurs is given by the following. So the probability that E or F occurs is the probability of E plus the probability of F minus the probability of E and F. Let's look at an example and utilize this formula, and we'll explain what this means here in a second. So suppose that 4 out of 15 doctors in a small hospital are trained in special procedures. 11 out of 15 are under the age of 45, and 2 are both trained in special procedures and under the age of 45. What is the probability that you are randomly assigned a doctor trained in special procedures or a doctor under the age of 45? Now, we know that the probability of getting a doctor trained in special procedures is 4 out of 15. There were 15 doctors and 4 of them were trained in special procedures. We also know from the problem that the probability of getting a doctor under the age of 45 is 11 out of 15 because there were 11 out of the 15 doctors that were under the age of 45. We also were told in this problem that 2 of the doctors were both trained in special procedures and, there's my and statement, under the age of 45. So, the probability of my or statement, trained in special procedures or under 45, I add the first 2 probabilities, 4 out of 15 plus 11 out of 15, but then I subtract my and statement, 2 out of 15, and I get 13 over 15, or approximately 0.8667. Sometimes events have no outcomes in common. We call these mutually exclusive events. We'll talk more about mutually exclusive events in Chapter 5. Let's look at an example. Determine whether the events are mutually exclusive. For a survey on campus, a sophomore or a history major is chosen. What do you think? The events are not mutually exclusive, and this is because it may be the case that a student is a sophomore and a history major, right? They can be both. Let's look at this example. Choose a Diet Cola or a bottle of water out of the refrigerator. What do you think? That's correct. The events in this case are mutually exclusive. And that's because the drink chosen cannot be both a Diet Cola and a bottle of water. It has to be one or the other. In the case that E and F are mutually exclusive events, the probability of E or F is just the sum of the probabilities of the events. And this is because the event E and F cannot occur, so the probability of E and F is 0. So our subtracting P and F, we're just subtracting 0.